So today I'm going to talk to you about one of the weirdest areas of physics, quantum mechanics. You might have heard something about a cat being both dead and alive, or even how quantum computers are going to change the world. But the real physics is even stranger and less cruel to cats. First, let's talk about one of the most well-known experiments in physics, the double slit experiment. Picture a wall with two slits in it and another wall behind that. Now, imagine throwing darts randomly at the wall, much like I do when playing actual darts. Some will hit the first wall, but some will make it through the slits and hit the back wall in roughly the same shape as the slits. Now, if we take electrons and shoot them through a similar setup, we would expect the same type of pattern, right? Well, it turns out this is not what happens. Instead, what we see is a pattern of bright and dark spots, where the electrons hit the wall in what we call an interference pattern. We see this even if we slow the whole thing down and fire the electrons one at a time. The electron is behaving as if it is a wave, by going through both slits at once and interfering with itself. But this is really strange, because we know that an electron is a particle. And we see this not only in electrons, but also in atoms and even molecules containing hundreds of atoms. Well then, you might ask, why does this not happen to me when I go through a door? Well, I have left out one tiny detail of this experiment. The size of the gap must be similar to the size of the wavelength of the object, and larger objects have smaller wavelengths, and so would require impossibly small gaps. However, there is no reason that we cannot, in principle, do this experiment with larger objects, such as viruses. But our strange experiment gets even stranger. Suppose we want to figure out which slit the electron goes through, and we set up a detector beside the slit. Then the interference pattern will disappear and be replaced by the darts-like pattern. It is as if the electron knows that we are watching it. So what have we learned from all of this? Well, matter can act like both particles and waves, and also that the act of observing a quantum system has a fundamental effect on that system. One interpretation of all of this is that a quantum particle doesn't exist in one state or another, but in all possible states at once. It is only when we observe its state the particle is forced to choose one possibility. This is a pretty profound philosophical idea. Now, think about that next time you play darts.